All right, today we're going to pull back the curtain on a really clever trick that helps AI see the world a lot more like you and I do. It's one of those fundamental building blocks that makes computer vision faster, smarter, and way more reliable. We are talking about pooling layers.
I mean, really think about it for a second. How can a self-driving car see a stop sign, whether it's way off to the right or on the left, or sitting right in front of it? Or how does your phone's photo app find your friend's face in a huge group shot, even when they're kind of peeking out from the corner?
You see, the real secret is being able to summarize, to see the bigger picture without getting totally bogged down by every single tiny, irrelevant detail. And that is the core idea we're going to unpack right now.
So, when an AI looks at a picture, it sends it through a process like this one. It's called a Convolutional Neural Network, or CNN for short. It starts with just the raw pixels, and then it passes them through layers to find basic features, like edges and curves. But deep inside this pipeline, a couple of major challenges start to pop up.
So, let's set the stage. Let's look at the very specific problems that engineers were banging their heads against to make computer vision actually work in the real world.
As the network starts analyzing an image, these first few layers create what are called feature maps. And believe me, these maps are massive. We're talking about just a gigantic amount of data for every single image, which right away creates our first big hurdle.
And here they are. Let's call them the two villains of our story. First up, you've got computational expense. Trying to process all of that data is incredibly slow, and it just eats up computing power. But the second one, this one's really tricky. Location dependence. The network becomes too literal. It can only recognize an object if it's in the exact same spot it first learned it in. And this, right here, is the crucial point. If the AI learns what a dog's eye looks like in the top left corner of its training photos, it might completely fail to see that exact same eye if the dog happens to be in the bottom right of a new photo. It just lacks flexibility. It doesn't get that the feature is what's important, not its exact coordinates on a grid.
Okay, so how do we fight these two massive problems? Well, we introduce a hero into our pipeline, the pooling layer.
So a pooling layer is this really elegant and surprisingly powerful solution. Its main job is to shrink, or what we call downsample, that giant feature map. It looks at a little neighborhood of features and basically summarizes them all into a single value, keeping the important stuff and just tossing out the noise.
And this simple act of summarizing doesn't just make things smaller. Oh no. It has these profound, absolutely game-changing effects on the entire AI model. And here's the big payoff. First, by shrinking the data, it dramatically cuts down on the number of calculations you need to do. That makes the AI way faster and more efficient. Second, it directly attacks that location problem. By summarizing regions, it makes the network care more about whether a feature is there, not exactly where it is. This is what we call translation invariance. And third, it helps prevent something called overfitting. Overfitting is basically when a model memorizes its training data so perfectly that it can't handle any new images it's never seen before. It's like a student who memorizes all the answers for a test but has no clue how to actually solve the problems.
Now, pooling isn't some one-size-fits-all solution. There are actually a few different ways to do this summarizing, and each one has its own strengths and is good for different things.
So let's look at the two heavy hitters in the world of pooling. They sound kind of similar, but trust me, their approaches and the results they give you are totally different.
First up is max pooling. I like to think of this one as the detail detective. It scans a small patch of the feature map and asks one really simple question. What's the most intense, most important feature in this little area? And then it just picks that single highest value and throws the rest away. This is awesome for preserving the sharpest, most defining features of an object, which makes it the go-to choice for a ton of object detection jobs.
And look, this shows it perfectly. As that little filter slides over each 2x2 square, it just looks for the biggest number. In this case, it's a 5. And that's the only piece of information that gets to move on. It's kind of ruthless, but it's super effective at highlighting what really matters.
Now, on the other end of the spectrum, you've got average pooling, which I call the mood analyst. Instead of hunting for the single most intense feature, it looks at all the features in that little patch and just calculates their average. This gives you a much smoother, more general summary of the region. Yeah, it might lose some of those sharp details, but it's fantastic for getting the overall vibe of a texture or a background. It gives you a more holistic view.
And then there's this powerhouse variant called global pooling. This technique takes an entire feature map, not just a tiny patch, and boils it all down to a single number, either the max or the average. It's a pretty extreme form of data reduction, but it is incredibly effective right before the final decision-making layers of the network to keep the model lean and stop it from overfitting.
So let's zoom out for a second. When you put all of this together, what have we actually accomplished? Well, we've fundamentally changed how the AI processes what it sees.
Let's just walk through that journey one more time. We start with a problem. These huge, rigid, location-dependent feature maps. The pooling layer steps in and intelligently shrinks them down. What we get is a compact, flexible summary of an image's most important features. And the final result? An AI that is dramatically faster, way more efficient, and so much better at finding objects, no matter where they are in the picture.
Pooling layers are, without a doubt, a brilliant solution. They make AI vision so much more robust by teaching it what to ignore. But that efficiency, it comes at a cost, right? And it leaves us with a really critical trade-off to think about. In the process of summarizing, of throwing data away, what subtle but important information might be getting lost forever?